Thank you so much, everyone. Thank you. I'm very excited to be here today, especially to talk about like how AI will change the way that we build data architecture. It was like a huge moment for me when I realized that my career is possibly going to change quite rapidly with the AI, and then I started to realizing the different ways that we can apply it. So to kick things off, first a little bit short about me. Who am I? My name is Petter Burenvan. I'm a founder and CEO of a startup called Uninall. We're an enterprise search company that helps data literacy, basically helps companies to easier find data, get value out of data, and get insights. Before working at Uninall, I was working as a head of data and process digitization at a private equity fund called EQT for about 6 years. And prior to that, I was heading business intelligence at Spotify. And I was amongst the first 300 employees. So I had an amazing journey. Throughout my 20 years, I've worked with several varieties of data architecture. So Inmon, Kimball, I've worked with data mesh, I worked a lot with the modern data stack, and I also, of course, work with Oracle and Microsoft databases due to my uh, age, I would say. So, and throughout my 10 last years, I've been mainly focusing on management things and advise a lot of the portfolio companies within the private equity fund as well on how to set up data architecture and data strategies. So, enough about me. So, before we get started, what is the problem that we're trying to solve? So, I really like this quote from Albert Einstein. We cannot solve our problems with the same thinking we used when we created them. Why have I picked this quote? Because throughout my 20 years, I've actually seen history repeat itself, that we're trying to solve problems and we create new ones. I've seen centralization, decentralization, going back to centralization, and then we are adding a bunch of tools on top, which is actually adding to the problem instead of actually solving it. And I'm actually going to give you a little bit history lane, like where we started off. And the thing is that even though that I'm talking about history, a lot of you guys might be in this specific state. It's my history, like where I was back into 2008. So during 2008, Microsoft SQL Server was really big when it came to data warehouse building. We had the Kimball. I still remember I still have the Kimball book, I think, discussing dimensional modeling, how to build fact tables, how to build the fantastic basic data platform where you have data across every field, everything from sales to finance, and everything was interconnected. So it was the utopia of what we wanted to actually achieve by integrating all solutions to a singleized and central platform with a high performance. We want to have unified access instead of having to go through the ERP system and the CRM system to extract data. We wanted to have just a pure data warehouse where we could just basically pick everything from there. And we also wanted to, of course, have access control. Unfortunately, some of the challenges, and not maybe in the initial phase, but after a couple of years of maintenance, you stumble upon a couple of challenges, which some of the challenges you're still facing today. Dependencies on individuals. Why is that? Because a data warehouse is a very complicated matter. It's typically you have to learn how the business works. You have to learn exactly how the data itself, how to transform the data, how to optimize the indexing and the processing of data. And having an individual that knows both all the in and out of technology and the business, it's quite difficult. It's not that everyone in the organization knows how to do that. So what happens is that typically the individuals with a lot of mileage within the same organization are able to maintain the data platform. So you get very dependent on individuals, and you can see that very often. Typically, they're the architects. And what happens then when you're dependent on individuals? Onboarding of new talent becomes extremely hard. Because when a junior person arrives at a company, they always have to ask the senior person, can I do this? Can I do that? What does this actually mean? Because all the ifs and buts in the data transformation are not always well documented. I know from being an engineer, I'm not always documented my data warehouse properly. And another very big problem is the problem of innovation. Why is that becoming a problem when you build a monolithic data warehouse? Because whenever you build something that might break, you're breaking the entire chain, the entire data warehouse. So you might be innovating for the finance department, but then all of a sudden the sales department starts crashing, or vice versa. So what do? You start generating these architectural boards, these architectural guidelines where it says you can't deploy unless you follow these very strict procedures. And that is actually hindering our ability of innovating, because innovation comes from experimentation. And experimentation is all about, I don't know the future. I don't know how this works. Let me try something out. And we're killing that by having all of these toll gates from architects. And as I mentioned, the single point of failure. This is 2008, but I know a lot of companies that I work with still has this problem. And again, just going back to history lane, I know that a lot of you guys have heard about data mesh, but there was a predecessor to data mesh, which was the self-service BI. So self-service BI, you've probably heard about, some of you that are a little bit older, maybe as old as me, ClickView and Power Pivot, where all of a sudden a business person could go to a consultant and ask them, could you build me a solution? I don't want to mess around with my data architects anymore because they're so freaking slow. So please build this solution for me. And it actually worked for a while, because then all of a sudden the consultant could come in, they could mash up some Excel spreadsheets, they could collect some data from the data warehouse, don't bother about coordinating with IT whatsoever. And what we achieved was rapid delivery. We achieved autonomy. So the person that actually sat on the budget could actually control what is happening. And also effective communication. I could talk to one person which actually understands my business. And that is super important for a business person to actually feel. But what happened? We started generating a bunch of data islands which became extremely hard to maintain, because all of those spreadsheets, they were not properly governed. All of those small queries nobody knew about on the data side. So whenever somebody actually changed the data model, everything started breaking. You didn't really know where the data was coming from. So could you really trust, is this data correct? And then a very common problem, you could see the same metrics in two different reports showing you the different numbers. And that became a huge trust problem. Didn't know when it was refreshed, and who is accountable when something is wrong. Which number should I look at? Then we had the amazing thing that happened with the cloud data warehouse. And one of the most fun thing for me, or like realization that I'm becoming a dinosaur, I actually asked my team quite recently, how many of you know how to index a table? Do you know what a cluster index is? Do you know what a covering index is? And they were like, no, I don't have a clue. And that was like, all my teams are data engineers and data scientists. And that is due to the cloud data warehouse. All of a sudden, you don't have to think about how you partition tables, how you cluster tables, how you follow the execution patterns in the data. You could just load petabytes of data in a single table and get really rapid response time. And that enabled amazing analytics. So working at that time at Spotify, I remember we could all of a sudden start analyzing how people were interacting with the Spotify client, exactly how they clicked, where they didn't click, and everything like that. And that would have been impossible with a SQL Server engine, or Oracle engine for that matter. So we could really get rapid delivery, because all of the cumbersome processes with building a data solution we could just avoid. We didn't have to think about performance issues anymore. We just added more compute power whenever we needed. So we scaled up 10 times the speed of delivery all of a sudden. We could start getting real-time reporting. We could also start doing some predictive analytics, because we had so much data from history, and we can start seeing patterns on the data usage, hence predicting the future. But what did this actually do? This actually amplified the same problems as we had before: centralization, decentralization, trust, and all of those issues. So what happened? All of a sudden, a bunch of engineers came up with different types of solutions to how to solve the problem. So we started building this ecosystem of tools and processes and technology to be able to resolve all of the trust problems. But all of these tools are actually adding more to the problem because we're creating a much more complicated world for us data engineers or data scientists to actually navigate all of these things. So what has actually happened? We are starting to narrowing down our skill set because I cannot phantom all of these technology. I need to limit my scope to a certain extent of technologies. And I don't have any time anymore to understanding how the business works. So when a business asks me a question, I need to think about my DevOps. I need to think about my quality and unit testing. So I'm not anymore, close to the business anymore. So as I mentioned, what has happened? We've actually started to creating a bunch of processes, roles, and tools for mitigating the problem of what we previously had, but 10 times worse because we have amplified the speed of delivery. We have data engineers, we have data scientists, we have data architects, we have scrum masters, we have a bunch of data governance specialists, tools such as data cataloging, data quality, data observability, data governance. And then we do have these amazing proxy roles. What are these? They are the people that helps us translate what a business is saying to the engineers and what engineers are saying to the business. So we always have a proxy. And you guys have played the kindergarten game when you're whispering in somebody else's ear and you notice what happens after a couple of rows of communication. So we have product owners, we have data owners, we have data stewards and data analysts. And all of a sudden, if I want to get something done, it takes ages because it has to go through a rigorous process. Because going through all of these roles, all of these technologies requires rituals like if you're using Scrum, you have to have your sprint planning. If you're using whatever is safe, you have to have your program increments and all of those different type of roles that is required for that. And then you have to have prioritization. And there's a poor guy somewhere in sales that doesn't know how much have we sold this month? Am I going to lose my job or not? And then there is no possibility of answering that. It's just, okay, you're fired. Now you lost your job. But no, but the kid, joking aside, it becomes like silly the way that we're operating right now. So going back again to my previous quote where I said that we need to fundamentally change the way that we think about solution when it comes to this architectural problem. Adding layers of complexity is just adding layers of complexity to the data literacy. But the big thing that happened to me for about 2 years ago is when I realized what AI could do in this sphere and how we can fundamentally change the way that we interact with data and how we interact with the business side. So what are the different operations that I definitely see in a very near future will change? Reduce the dependencies on data specialists. So all of you guys already know in your organizations, that's the person that we need to talk to in order to get our shit done. And that is creating a bottleneck in a lot of organizations, and I think that that's going to change. Bridging the knowledge gap. Again, having the people needing to have proxy individuals to be able to communicate with the person that is actually delivering stuff, that is also going to change. And we're going to simplify data exploration. So if I'm not sure of exactly what data that I'm looking for, I just have a business problem. Instead, again, going through that data specialist or that proxy role, I myself, I need to be empowered as a business person. So I'm going to be a little bit progressive here and actually say some of the roles that I definitely think will change in a not distant future. So data stewards and data owners typically work in a data governance environment where I see data documentation, data classification, and data compliance. Why do I think that these will change? I'm going to showcase a couple of examples quite soon in the next coming slide, but documentation is something that we can automate with the help of LLMs and vector databases, and I'm going to show you that later. Same thing when it comes to classification, because identifying information and classifying them, that's what LLMs are optimized for. Data compliance. So already we can see a lot of amazing startup working in the legal space where you can actually start asking questions. Even today, you can go to ChatGPT and actually get quite good answers when it comes to legal questions. But imagine if you have tailored solutions specifically for data compliance, it's definitely going to change the way that we interact. So I think that these roles will possibly be redundant. Bridging the knowledge gap. I think that the product owner with the processes of project rituals, where they are focusing a lot in communication back and forward, that will be significantly changed. I don't think that this role will disappear because you still need to have someone that do prioritization and make sure that they set a vision for the data product itself. But the communication part that is taking up sometimes 50, 60% of their time will be changed. And the Power BI building for the analytical engineer. So analytical engineer will shift roles to actually focusing on building good data foundations instead of building very tailored and narratives for business use cases by building Power BI reports. I'm going to double click on the last part, especially because at Union All, this is the part where we are focusing the majority of our time, and I can show you a couple of use cases how we have tackled specifically this process and this problem. So, why are dashboards problematic? Like, we all know we hate and love them at the same time. They can be beautiful, but they can be extremely confusing because a dashboard contains hundreds of metrics and every single click actually filters hundreds of metrics. And if you're not a super specialist within a specific dashboard, how the hell will you know what is happening? What is this showing me? So a dashboard, one thing that is really good at, though, is to be able to show you repetitive numbers. So if you're following up budgets, forecasts, sales numbers, fantastic. But why don't you actually rely on your CRM system or your finance system for that? Where you're using a dashboard, the big question comes. But that's a different problem. But for the repetitive things, a dashboard is fantastic, but for a new user coming in and seeing a dashboard is just purely confusing. What is a much more natural approach to analyzing data? And we can see my personal behavior when I'm using ChatGPT, and I'm pretty convinced that you guys have changed behavior as well when it comes to asking things in Google compared to ChatGPT. So you want to have a very clear questions answered and only that answered because you don't want to be, confused by a bunch of noise that is not really relevant to the type of question that you're asking. So again, if I'm a CEO of a small company, I want to possibly ask, our sales is increasing, but my margin is going down. Why? The computer then will say, it's due to FX impact on SEK versus euros. Your cost in US and your sales increase is in Sweden. Very straightforward. I don't have to go through a bunch of metrics to figuring this out. So what is actually happening in reality when we don't have this technology is that CEOs have a bunch of armies of controllers that, business controllers they're called, and Excel people. So they go and hack away different spreadsheets and they come back to you and they can answer a question. But what's the big problem with that? First of all, it takes time. It takes money, it takes resources, and it's also not giving me the rapid response into modern business that I actually need. It's on quarter end, month end, and best case scenario on the weekend, or I mean, the last day of the week. So if I do a follow-up question then, can you show me breakdown of sales of product A in Sweden versus US? Sure, here's the breakdown. Then you see a chart. Can you provide me a list of customers that buy product A but not product B in the US? And the computer says, sure, here are the customers that buy A but not B. And here I get an insight on how that I should steer my strategy. I should start selling product B to these specific customers. And I'm not confused by any other noise when it comes to the numbers. How will this be possible? Because this, if I would have had this talk for 5 years ago, people would think that this is, fictional movie that not going to be possible. But some of you guys already know about vector databases, you know about LLMs and things like that. So this is actually not far from where we are today. So the first thing that you have to fundamentally know in order to be able to build this architecture is a so-called RAG architecture. And in the RAG architecture, there are three main components. There is the knowledge source, there's the retrieval model, and there is the generative model. The knowledge source is the source that you already have. That's your data warehouse, or it might be your SharePoint, or wherever you might have quality data. The retrieval model is so-called vector database. For you that doesn't know what a vector database is, it's basically a new database form which indexes data into vectors. And it's just simply put, it's just a new index. Very similar to clustered index and non-clustered index. It's just a new index. But what a vector does, it takes a full sentence and converts it into a vector, which then can be searchable with other text, and you can do a lookup between text blobs, basically. And what does the generative model do? It actually can convert that vector into a meaningful natural text so that a human understands what this is about. So how do we combine these technologies to build an application that actually resembles the use case that I showed you before? It's quite simple. You have your data warehouse. In order to be able to do a vector, you need to use what's called an embedding. Embedding just change a text to a vector. So first of all, the first step is your knowledge source. You have to take that and convert it and put it into your vector database. The second thing that you can do is that you can start querying that data by, again, taking a natural text, sending it through an embedding, which converts it to a vector. And what will happen is that it's going to try to do a matching between the question and already existing data sets that you have in your vector database. And very similar to a Google search, it's going to give you a bunch of search results in a descending probability. And you yourself, as an engineer or an organization, need to just define a cap. Like, how good of a match do this need to have in order for me to actually retrieve this information and send it over to my generative model? And what the generative model then does is that it generates a natural language response to that vector. So how do we avoid hallucination? Is as simple as this. You make sure that you don't use the LLM for content, but rather converting your content into natural language response. And that's the biggest difference, and that is what very often people get confused about. LLMs, don't use them for content, use them for just converting your own content to natural language response. This is a very simple architecture, so what's the next phase? Because first thing first, vectors are not super good with numeric values. And I hope that we have some machine learning people and data scientists in the room as well. A lot of you guys are quite familiar with not trying to use numeric value too much in your machine learning algorithm. What you typically try to do instead is that you try to convert numbers to distinct values. So if a number is high, you say high, medium, low. If something is good or bad, you change it to good or bad or green, amber, red. And if you do that with your data, you could actually store that as a text blob. And one way that you can do that by is to actually first generating a SQL that then does some transformation and send that through an LLM to actually generate a bunch of really interesting text blobs. And those text blobs can then be stored into your vector database. So whenever your finance CFO asks, how did we do last year in our revenue? Then that is a text blob that is already being stored, and it could actually answer that. Okay, good. Another very, uh, for some of you observant people that already might already know this, building this architecture with all of your data warehouse data in a centralized vector database will not really properly function. Why not? Because if you start scrambling amongst a bunch of different contexts, you're combining finance context with sales context with R&D context, and just asking people to just do searches, it's very likely that sometimes when a person does a search, it might get a wrong hit in a wrong context, such as I'm searching for something, it hits both finance data and HR data and R&D data. But in reality, these domains are extremely different. So even though my question might be a generic one, it needs to use my context and be a bit more sophisticated. So the way that you solve that specific problem, so you should not, as I mentioned, you should not put your entire data warehouse into a single vector collection. You have to separate them. And the way that you do that is by introducing a multi-agent AI system, where you specifically tell the AI and generate basically a RAG model for each data domain. And the data domains that I'm showing you here right now is based on the data domains that we have at Uninall. But the data domains that you might have if you're an enterprise, you might have HR, you might have R&D, you might have finance, where you're storing content about the individual domains in a single vector database or a vector collection. And then secondly, what you can do is that you can also start using specific LLMs that are optimized for that specific task. Because some of you might know that a lot of open source LLM are popping up every day, and the specific LLMs are quite small, so you can actually host them in a very small compute engine. And that could be very efficient. So how we have done this is that we have created 3 agents, one with search, one for Q&A, and one for code generation. And we're using different LLM models and different vector databases for that. But then another problem comes up. How do you know which of these that you should try to use? For that, you need to build a decision engine that decides this question, is this related to a search, a Q&A, or a code generating question? And I've seen a lot of different ways that people have solved this decision engine. Some have actually used a rule-based one. If the question includes this keywords, then send it over to here. Some other people, such as ourselves, we've used another RAG architecture for detecting that. So we try to match them with the appropriate text, and then we know where to funnel them, if that makes sense. So this is the next level of sophistication, that you start building multi-agent AI systems with very specific data domains. And now comes the magic, where I think it's going to be amazing when you guys like experience the feeling when you build something like this, is that you use the individual's context in the prompt of the question before sending it in to the multi-agent AI system. What happens? What's the biggest difference in the user experience? If I am a mathematician and asking a mathematical question, the LLM can reply back with a very detailed mathematical answer. But if I'm not a mathematician, I need to make sure that the LLM describes it as they would do for a 3-year-old. And that difference is enormous. I can today actually understand medical stuff quite well, even though that I don't have a medical degree. And the only reason for that is because I've trained ChatGPT when I prompt about medical stuff. That happens the same thing here. So, and how do you do this? So in an enterprise, of course, you need to make sure that you know somebody needs to log in, and then you can look up where this person belongs into the organization. You can store some content about that person. If you're a software company, again, you could create a login page where in the login page you define which company it is, the size of the company, the region. You can distinguish the role of this individual person, and then use that as a context when sending this into the LLM model. And it will have a huge usability impact. So how do we do this at Union All in practice, and what are we doing? As I mentioned before, we have built an enterprise search engine for making data literacy really efficient. And we have automated the process of generating a data catalog. And the way that we have done that is that you can just simply point to a table in your database, wherever that might be. You can point to any documentation that you might have, if that's a Wikipedia page or whatever. We merge these two, and we basically automatically generate the entire data cataloging procedure. We generate a data product description. We generate a data dictionary with very clear column descriptions. We generate example SQL queries that you can run on top of that data. We also generate use cases for that data. So whenever a business person actually looks up a data product, they can understand what this data set and data product can be used for. And what do we do for the end user? So the end user can now start communicating with the data that we have just created documentation for. You can search. I'm not sure exactly what I'm looking for, but this is the problem that I have. And then we can use semantic search to match that person with the right data set. And then from there, we can give the person a match to a data set, and the person can start asking follow-up questions on the data, such as, will this really be able to solve my problems? Secondly, after that, we automatically generate queries based on natural language. So the finance person says, what was our revenue last year? And it automatically generates a SQL code that can give that answer to the CFO. And lastly, on that number, you can ask follow-up questions as well. So if something pops up in your dimensionality that you don't really understand, you can ask questions about it. This is going to be a short demo of our product. This is just a showcasing of how you can leverage LLM and RAG architecture.
Introducing Union All, the software as a service platform that simplifies data sharing by providing data distributors with everything needed to create and manage their own data storefront. Get your data shop up and running in just minutes with 3 simple steps. Step 1. Add your first data product. Simply upload a sample CSV and PDF file and let the Union All AI agent handle the rest. Step 2. Customize your storefront. Choose colors and images that match your brand. Step 3. Share your data storefront with your customers. For data sellers, we offer the ability to publish on multiple external marketplaces, such as Snowflake, Google, and Amazon. Once your storefront is live, customers can easily explore and get matched with the datasets that best suit their needs. With the Ask Anything in the Chat feature, customers can simply describe their business problem and instantly be matched with the right dataset to solve it. If users want to access the dataset, they submit a request, which is then consolidated in your admin portal, collecting submissions from all marketplaces where your dataset is published. Union All, data sharing for all.
So I hope you got a little bit of inspiration on what you can do. Going back again to my previous example is, instead of forcing a person looking at a dashboard, now we can just give the business person the ability to just search for data, ask questions about data, and actually retrieve data. And I think that this technology will have a transformational effect in the way that we operate data in the future. There we go. I really like this next quote from William Gibson. The future is here, but it's not evenly distributed. And what does that mean? The cool thing is that we can see some companies really in forefront when it comes to AI. And then we have still a lot of companies that are lagging behind when it comes to adapting these new AI technologies. Uh, and and what I can see is that the companies that are investing heavily in this, they will definitely have a competitive advantage. So what can you do in order to get started? Like three very simple steps. The first step is, as always, when you work with data, ensure that you have good data quality. Because if you have bad data quality, regardless, it's going to always be bad despite technology. Second, adapt and try a vector database. It's not hard, it's quite easy. We're using ChromaDB, but there is a bunch of other open source tools out there that you can just run on your laptop. And then try using an API version of an LLM where you can just retrieve some vectors and send it back to the LLM and try and see how that works. So that concludes my talk. Thank you so much for listening. I hope you enjoyed it.